Welcome to our exploration of one of history's greatest minds. In this documentary, we trace the journey of Isaac Newton, from a solitary boy in rural England to the architect of modern science. Through his revolutionary insights into gravity, light, and mathematics, he reshaped our understanding of the natural world. Join us as we uncover the life and legacy of this towering figure. Isaac Newton was born prematurely on Christmas Day, 1642, in the small village of Woolsthorpe, Lincolnshire, England. His father, also named Isaac, had died 3 months earlier, leaving his mother Hannah to raise him alone. The infant was so tiny and frail that he was not expected to survive, yet he clung to life with a tenacity that would define his character. Growing up in the rural English countryside, young Isaac was surrounded by farmland and open skies, an environment that perhaps nurtured his later fascination with natural forces. His early years were marked by solitude, as his mother remarried when he was 3 and left him in the care of his grandmother, creating a sense of abandonment that lingered throughout his life. At age 12, Newton was sent to the King's School in Grantham, where he lodged with a local apothecary. Initially an average student, he soon distinguished himself through intense focus and a knack for building mechanical devices, such as sundials and model windmills. His education was interrupted when his mother, now widowed again, recalled him to manage the family farm, a task for which he showed little aptitude. Legend has it that he would often be found reading under a hedge while the sheep wandered unsupervised. This period of forced rural labor only deepened his desire for intellectual pursuits. And with the encouragement of his uncle and schoolmaster, he was allowed to return to school to prepare for university, setting the stage for his academic ascent. In 1661, Newton entered Trinity College, Cambridge, as a subcizar, a poor student who earned his keep by performing menial tasks for wealthier peers. The university was still steeped in Aristotelian philosophy, but Newton voraciously studied the works of modern thinkers like Descartes, Galileo, and Kepler. The Great Plague of 1665 forced Cambridge to close, sending Newton back to Woolsthorpe for 18 months of intense, solitary study. During this Annus Mirabilis, or Year of Wonders, he laid the foundations for his groundbreaking work in calculus, optics, and the laws of motion. Isolated in the countryside with only his thoughts and experiments for company, he began to unravel the mysteries of the universe. It was during his time at Woolsthorpe that the famous apple incident is said to have occurred. While sitting in the orchard, Newton observed an apple falling from a tree, which sparked his thoughts on gravity. He wondered if the same force that pulled the apple to the ground might extend to the moon, keeping it in orbit around Earth. This insight led him to develop the concept of universal gravitation, proposing that every mass attracts every other mass with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. Though the story may be apocryphal, it symbolizes his ability to derive profound truths from everyday observations. Upon returning to Cambridge in 1667, Newton was elected a Fellow of Trinity College and began to formalize his discoveries. He constructed the first reflecting telescope, using a mirror instead of lenses to avoid chromatic aberration, and demonstrated it to the Royal Society in London. This invention earned him widespread acclaim and membership in the prestigious society. Concurrently, he delved deeper into optics, conducting experiments with prisms to show that white light is composed of a spectrum of colors. His work challenged prevailing theories and established him as a leading figure in the scientific community, though it also sparked controversies with contemporaries like Robert Hooke. In 1687, Newton published his magnum opus, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, often called the Principia. This monumental work presented his three laws of motion and the law of universal gravitation, unifying celestial and terrestrial mechanics. Written in Latin, it used geometric proofs to describe how objects move under forces, revolutionizing physics and astronomy. The Principia provided a mathematical framework that explained planetary orbits, tides, and the behavior of comets, cementing Newton's reputation as a preeminent scientist. Its publication was supported by his friend Edmund Halley, who funded the printing after the Royal Society faced financial difficulties. Newton's work in mathematics was equally transformative. Independently of Gottfried Leibniz, he developed calculus, a branch of mathematics essential for describing change and motion. His method of fluxions, as he called it, allowed for the calculation of slopes and areas under curves, providing the tools needed for his physical theories. However, this led to a bitter priority dispute with Leibniz, which lasted for decades and tarnished Newton's later years. Despite the controversy, calculus became a cornerstone of modern science and engineering, enabling advances in fields from physics to economics and showcasing Newton's unparalleled ability to bridge abstract thought with practical application. Beyond science, Newton had a deep interest in alchemy and theology, spending countless hours in secret experiments and biblical studies. He believed that ancient philosophers possessed hidden knowledge about nature and sought to decode it through alchemical practices, often working in a private laboratory. Theologically, he rejected the doctrine of the Trinity and wrote extensively on prophecy and chronology, though he kept these views private to avoid controversy. This mystical side contrasted with his rational scientific work, revealing a complex personality driven by a quest for ultimate truths, whether in the laboratory or scripture. In 1696, Newton moved to London to become Warden of the Royal Mint, a position he took seriously, applying his analytical mind to combat counterfeiting and reform England's currency. He oversaw the Great Recoinage, ensuring the stability of the nation's economy during a period of financial crisis. His tenure was marked by rigorous investigations and harsh punishments for counterfeiters, demonstrating his commitment to public service. This role provided him with financial security and social status, allowing him to engage more actively in the Royal Society, where he later served as president, shaping the direction of British science. As president of the Royal Society from 1703 until his death, Newton wielded significant influence over the scientific community. He presided over meetings, fostered research, and engaged in disputes, notably with astronomer John Flamsteed over access to observational data. Under his leadership, the Society published important works and promoted experimental philosophy. Newton also continued his own studies, publishing Optics in 1704, which detailed his experiments with light and color. This period saw him honored with knighthood by Queen Anne in 1705, recognizing his contributions to science and the state and solidifying his status as a national icon. Newton's later years were marked by ongoing controversies, particularly the calculus dispute with Leibniz, which he pursued with relentless vigor, even chairing a committee that accused Leibniz of plagiarism. This feud reflected his combative nature and desire to protect his intellectual legacy. Despite these conflicts, he remained active in scientific circles, corresponding with scholars across Europe and revising his earlier works. His health began to decline in the 1720s, but he continued to work until near the end, embodying a lifelong dedication to inquiry that transcended personal rivalries and physical frailty. Isaac Newton died on March 20th, 1727, at the age of 84 in London. He was given a state funeral and buried in Westminster Abbey, a rare honor for a scientist, reflecting his monumental impact on British culture and thought. His coffin was borne by nobles and fellows of the Royal Society, and his tomb bears an epitaph that hails him as a genius who surpassed the human race. Despite his complex personality, reclusive, secretive, and often quarrelsome, his death was mourned as the loss of a towering intellect who had fundamentally altered humanity's understanding of the universe. Newton's scientific legacy is immense, with his laws of motion and universal gravitation forming the basis of classical mechanics. They enabled predictions of planetary movements, the design of engines, and the exploration of space, influencing thinkers from Einstein to modern physicists. His work in optics laid the groundwork for understanding light and color, while calculus revolutionized mathematics. The Principia remains one of the most important scientific books ever written, exemplifying the power of mathematical reasoning to decode nature's laws and inspiring centuries of innovation across disciplines. In popular culture, Newton is often remembered through anecdotes like the Apple story, which symbolize curiosity and discovery. His image has been immortalized in statues, coins, and literature, representing the archetype of the brilliant, eccentric scientist. Phrases like Newtonian physics and standing on the shoulders of giants, a modest remark in a letter to Hooke, have entered common parlance. This cultural footprint underscores how his ideas transcended academia, shaping not only science, but also the public imagination and cementing his place as an icon of the Enlightenment and human progress. Newton's influence extended to philosophy, where his mechanistic view of the universe inspired Enlightenment thinkers like Voltaire and David Hume. By describing nature as governed by immutable laws, he challenged religious and philosophical dogmas, promoting a worldview based on reason and observation. This shift contributed to the rise of secular science and the questioning of traditional authorities. However, Newton himself saw his work as uncovering God's design, believing that the orderly universe reflected divine craftsmanship, thus blending scientific rigor with theological conviction in a way that shaped intellectual history. Despite his achievements, Newton's personal life was marked by solitude and conflict. He never married and had few close friendships, often immersing himself in work to the exclusion of social bonds. His disputes with Hooke, Leibniz, and others reveal a sensitive and proud man quick to defend his honor. Modern scholars suggest he may have had Asperger's syndrome, which could explain his intense focus and social difficulties. This complexity adds depth to his legacy, reminding us that genius often comes with personal struggles and that his contributions emerged from a unique and sometimes turbulent mind. Newton's work in alchemy and theology, once dismissed as eccentric, is now studied for insights into his holistic worldview. He believed that ancient sages held secrets about nature's unity, and his alchemical experiments sought to transform matter, paralleling his scientific quest for fundamental laws. Theologically, his anti-Trinitarian views and biblical chronologies, though heretical for his time, show a mind grappling with faith and reason. These pursuits reveal that Newton saw no boundary between science and mysticism, viewing all knowledge as interconnected, a perspective that enriches our understanding of his intellectual journey. The Newtonian worldview dominated science for over 2 centuries, until Einstein's theory of relativity introduced new concepts of space and time. Yet, Newton's laws remain accurate for everyday scales, underpinning engineering, ballistics, and space travel. His legacy is not just in specific discoveries, but in establishing a methodology, combining mathematics, experiment, and observation that defines modern science. This approach has propelled advancements from technology to medicine, demonstrating how his framework continues to guide inquiry and innovation long after his death, a testament to the enduring power of his ideas. Today, Newton is celebrated in institutions like the Isaac Newton Institute for Mathematical Sciences and on currency, such as the British pound note. His name adorns laws, units, and craters on the moon, reflecting his ubiquitous influence. Annual lectures and prizes honor his memory, inspiring new generations of scientists. This ongoing recognition highlights how his contributions transcend time, serving as a foundation for education and research worldwide. By bridging the gap between the medieval and modern worlds, Newton not only explained the heavens, but also helped forge the path to contemporary scientific thought. In reflecting on Newton's life, we see a man of contradictions, a reclusive genius who shaped public science, a rationalist dabbling in mysticism, a humble seeker embroiled in disputes. His story reminds us that great discoveries often arise from solitary contemplation and relentless curiosity. From the apple orchard to the halls of the Royal Society, Newton's journey exemplifies the human capacity to unlock nature's secrets. As we look to the stars or study a falling object, we engage with a legacy that continues to illuminate our world, proving that one mind can indeed change everything. Isaac Newton's legacy endures as a cornerstone of scientific thought. His laws of motion and universal gravitation laid the groundwork for centuries of discovery, from space exploration to modern physics. Though a complex and often solitary man, his intellectual brilliance illuminated the cosmos. Thank you for joining us on this journey through the life of a true visionary.